Hey guys, this week's notes are on quadratic function word problems, and so the first thing we're going to do is look at this example where we are talking about a golf ball flying through the air, and we are going to compare time versus its height. In order to go through word problems, we need to go back to our basic key characteristics. Those are not my key characteristics. There we go. Quadratic key characteristics. So all the questions are going to be dependent on these things. We could be asked about the x-intercepts, the y-intercepts, the axis of symmetry, the vertex, and then of course our domain and range. And so we're going to go through and point out which questions are really referring to these 6 characteristics. In this word problem, they give us the equation. So the first thing, of course, we need to do is fill in the table and the graph. We're going to do that by heading over to our calculator. We're going to use our y equals button because, of course, f of x is the same thing as y equals. And so once I've plugged in the equation for y equals, I'm going to go to the table so that I can fill in the table. We are going to start with 0 as our smallest number in our x, because when we're talking about our x in this problem, it's time, and time cannot be negative, so we know that we're going to start at 0. Okay, and then we're going to stop when the height ends up back at 0, because of course our ball cannot penetrate into the ground. We are going to stop when it hits back at the ground. So we are only going about this 5 or 6 seconds. I have this all filled out for us, so I'm just going to refer to this now. Okay, and then plotted is our function. It should look like a parabola still, with our points at 0, 1 second, 2 second, 3 seconds being all the way up here at the top, 4 seconds, 5, and back down. First question on this page is describe the graph, and so of course we can say that it is a parabola. Okay, right, the curve or our U shape. And then we are specifically saying that this parabola is opening down, and that the vertex is the maximum point. Okay. Next it says, what are the independent and dependent variables for this problem? Remember that independent is always our x values, and dependent is our y values. So what are we plugging into our equation versus what is our answer? And in this problem, right, if we go and look at our table, we're plugging in time so that we can determine height. And so we'll say that x value is going to be our time in seconds, and our y values, our dependent values, is going to be the height in feet. Next, it wants to know what a reasonable domain and range is. And because we're talking about domain, or our x values, which we just said was time, we know that our time is going to be dependent on not being negative, right? We can't go negative in time. And then it's going to stop when we said that the height hits the ground, okay? And so if we look over here at our table, our height is hitting, the height of the ball is back at 0 or back at the ground somewhere around 6 seconds. So a reasonable, right, domain is going to be from 0 is less than or equal to x is less than or equal to 6. And then our range, or our y value, our height, is going to be based on the fact, again, that we're not going to penetrate the ground. A golf ball does not typically have enough oomph or weight behind it to penetrate. So we're going to go from 0 on either side, and then all the way up to our maximum, which according to our table is actually 141, not 140. So our range down here will be from 0 to 140. How long is the golf ball in the air? How long is referring to time. So we need an answer that is going to be an x equals answer. And so an x equals answer for how long total time is going to be from our starting x-intercept to our ending x-intercept. So we can say our x-intercepts tell us that we are going 6 seconds. Whoops, except that's down there. So our total time, our x-intercepts tell us that we're going to be in the air for 6 seconds. It says, what is the maximum height? Okay, we already talked about maximum usually pertains to our vertex. Okay, and so in this problem, the vertex, we can see the highest point is at 3,141. Okay, the other way we do that without a graph is by actually solving for the axis of symmetry, which is x equals negative b over 2a. And in this problem, our equation says that it is negative of 95 over 2 times negative 16, which ends up being negative 95 over negative 32, which gives us a positive 2.97. We definitely can say that that is close enough to round to 3, so we will use our vertex of 3,141, and we can say that the maximum is going to be the 141 feet. If this number had been much smaller or further away from 3, Dad?
Yeah.
I'm recording. So my 3 is, if that number had been a lot smaller or further away from 3, closer to 2.75 or 2.5, we would have plugged that value into our equation and solved for y in our calculator. Last couple questions here. It says how long after it has been hit did it take to reach? So remember, how long is still time. So we're looking for that x equals answer. How long for our max is going to be our axis of symmetry. Okay, and we already solved for that on our last page. So we said that the axis of symmetry was 2.97, or we rounded to x equals 3. What is the height of the ball at 3.5 seconds? So if they're giving you time, that gives you an x equals. Okay, and so they're solving for what y equals. So we can simply plug in to solve for y. We'll get negative 16 times 3.5 squared plus 95 times 3.5. When I plug all of that into the calculator, we end up with y equals 136.5 feet. We can check ourselves by going back to our graph. Okay, and it said at 3.5 seconds, we are all the way up here, right, between 35 and 140. Our next question says, at approximately what time, so what does x equal? At 65 feet, we know that y is feet. So this one we don't know how to solve mathematically, so we are going to have to refer to the table and the graph. And so if we look at our graph and we go to 65 and see where it crosses both times, remember it's crossing both places, we can say that that is about maybe 0.75 and about 5.25 maybe. So we're going to say x equals 0.75 seconds and x equals 5.25 seconds. Last problem, it says that the golfer has now hit from a tee elevated 20 feet above the fairway. How is that going to change the graph? And we're going to say that that starting point, or our y-intercept, went up 20. And if we write an equation, it means that we're just going to add this up 20, remember our transformations, we're going to add this to the end of the equation. So now our y equals equation says negative 16x squared plus 95x plus 20. Finally, it asks us to create a new graph using this new equation. And so what happens? What we notice is all of our numbers compared to our numbers before are going up 20. I have 20 versus 0. I have 99 instead of 79. I have 146 instead of 126. See how all we've done is added that 20 to the very end. And then just the same, we can look at the table or the graph and see that everything now is up higher. This is up at 160 versus at 140 and so on. Should still look like a parabola. It's still opening downward. Alright, good luck on this week's assignment, guys. Make sure you go to tutorials this week when you have questions.